Let's find the zeros of this polynomial function. So notice that all the terms here, they share something in common. Do you see it? Yes, they all have x's, and at most, they all share at least two x's. So this is a polynomial which can be factored out. So let's go ahead and factor it out. Because it starts with a negative, we're going to go ahead and make it easier to factor by multiplying all the terms by -1 so that that first term is a positive. So when we do that, it just makes it easier to factor. Now let's go ahead and factor out that GCF of x squared. And we're going to write what we have left. We have a trinomial, which can be factored into two binomials. Let's go ahead and factor that. And so now we have two factors. We have x minus 2. We can set that equal to 0. And we can take the outside and set it equal to 0. So when we do that, the first one, once you solve that for x, take the square root of each side and x would equal 0. The other one, x is going to equal 2. And those are our two zeros, 0 and 2. Before I reveal the graph, a couple of things you should note that can give you an idea already of what the graph is going to look like. This is a fourth degree polynomial, which means it's an even function. And recall that even function is both ends up or both ends down. The fact that our leading coefficient is negative means that it's going to be both ends down. We also see that for turning points is n minus 1. So since the degree is 4 take away 1, that's going to be 3 turning points we can expect. Also, the x-intercept is the point where it touches the x-axis. And so once we graph it, it's going to look like so. And notice that we have 3 turning points, 1, 2, 3. And notice our x-intercepts are at 0 and at 2. Now you should know that not all polynomials are factorable. So you may need to use another method like the rational zeros theorem.